Hi, my name is Junpeng, and this is my CF5200 in the Practicum to proof of concept for the final project. The goal of this project is to build an end-to-end expense reporting data pipeline using my Sukulize MongoDB Address and my Soku. I divide the pipeline into a different independent executable program. The pipeline begins with synthetic CSV transaction generation, load operational data into Sukulize, generates expense report, and generates store those reports into MongoDB database, then load a dimensional analytical data mart and one big table into my Soku. Then here is my program one generate synthetic employee, clients, project, and corporate car account and transaction CSV files. Each CSV file follows the required naming convention, such as last name, first name, bank, month, and year. The employee information is not stored inside each transaction row, is inferred during ingestion from the file name and corporate car account. And programming two is going to be create the normalized supervised operational database. The simmer contains employee banks, credit card accounts, clients, projects, employee projects assignment, categories, subcategories, currency, import, batches, and transaction records. The many-to-many relationship between employees and projects is implemented using employee project. Programming two, three is going to be processing the incoming CSV file, like it validate required columns, days, amounts, and currency, category and subcategory combination, and credit card ownership. Duplicate imports are prevented using both the file names and an MD5 file hash. Successful files are committed to Superlight and then moved from the intake directory to archive directory. Which is going to be right here. And programming for generates the expense report from the operational transaction. Buildable transaction can also allocate to one project between multiple project, and non-buildable transaction remain unallocated. Programming file then loads the nested expense report documents to MongoDB. Here is one of the expense stored in MongoDB, and usually it was showing right here. And Programming 6 create the analytical MySQL data marts. I implemented 6-dimensional days, employee, client, project, category, and currency. The central fact table is actually like fact expense. Then the green of the fact table is one transaction allocation to one project. For the example, like one $200 transaction split 50-50 between two projects create two $100 fact row. Like this prevents double counting. The fact table and one big table heavily indexed and partitioned by data key using MySQL range partition. These support the common analytical access patterns such as date, employee, client, project, category, and report-based queries. Programming 7 combines the reference data from SQLite with approved expense report allocation from my Mango database and wrote the MySQL data mart. The source contains 1,634 transactions, which because some of transactions are split across the project, these become 1,876 allocation level analytical rows. I can show you guys the right. Yep, which is gonna be right here. And finally, programming 8 independently validate the entire pipeline. I will run it now. As we can see, it will validate all the data. The final validation confirms that SQLite contains 1,600 34 transaction Mango database also represent 1,634 transaction, and the allocation level source contain 1,876 rows. Both the MySQL fact table and one big table contains exactly 1,876 rows. And then I will open up the report. The final R Markdown report connect directly to MySQL analytical database. I can show you guys right here. It includes the category analyst, client and project analyst, monthly expense analyst, and a figure generate directly from OLAP data mart. Overall, the proof of concept demonstrates a complete pipeline from CSV injection to normalized operational storage to document-based expense reporting, and finally to an index and partition analytic data mart. Here's all of my presentation and the project. Thank you.